Welcome back to the OpenUK Mini Moo lessons. This is lesson 7 and it's called Trainer Glove. You can start and stop this video at each step if you need more time to keep up with the lesson. Robin loves Bollywood dance, but needs some help learning the moves. They wonder if it's possible to use their glove to help them learn a sequence of moves so that they can practice for a competition they're entering. Instead of watching a video or dancing in front of a mirror, Robin thinks it will be possible to program a sequence of moves into their glove and get the glove to beep a different note when they move their hands to that position. That way, their glove will be training them to learn the dance sequence. Robin has heard that you're a real whiz with your microbit coding now and has come to you to ask for some help with the code. Can you help them with this problem? In today's lesson, you will help Robin to design a program for the Trainer Glove project. By doing this, you will learn about event handlers, if-else statements, variables including string variables, string literals, indexing into string variables, passing parameters to functions. You will also learn a bit more about the benefits of open source. You will need your assembled Mini-Moo glove, the MakeCode web coding editor, and a mirror to practice your dance moves in front of. Before we can write this program, we need to learn a little bit about strings. A string is a shorthand name for a character string, and it's a convenient way to store lots of characters, that's letters, digits and symbols, in a specific order. It's called a string because you string together the characters into a sequence. A picture will help here. Imagine making a name bracelet for Robin. You would get a piece of string and then thread each of the individual letter beads, R-O-B-I-N, onto the string in the correct order. This string then has 6 letters, or characters, and they're in a particular sequence that spells out Robin's name. The R is the start of the string, which is position 0. The O is next, and it is at position 1, and so on. The string is said to have a length of 5 characters. Now we know what a string is. Let's decide how we will use a string in this program. Because Robin may want to learn lots of different dance moves, we will use a string as a way to store the sequence of moves as letters. That way, if they want to learn a different dance move, they can just change the letters in the string. You will see in a moment that this will make the program much easier to write. For this first dance sequence, Robin tells us the gestures they have to learn are up, flat, left, right, left, right. Let's use the first letter of each move as the name of the gesture. So, U will mean up, F will mean flat, L will mean left, and R will mean right. Start by putting the usual on-start play note 1/16 in your program. You should be an expert at this part now. Make a new variable called moves. As this variable will never change while the program is running, make sure the name is spelt using all uppercase characters. This is a convention that programmers use to remind you it is a constant and won't change throughout your program. From the Advanced Text palette, grab the block with 2 quote marks and join it all up into a Set Moves to quote block inside the OnStart event handler. Type the characters U, F, U, F, L, R, L, R inside the quotes, no spaces though. And this will be used by the program as the sequence of expected dance moves. Now, the next bit of code is a bit big, so I'm not going to read all that out to you. I think I will lose my voice otherwise. Here it is. You should be able to find most of the blocks as you have used them before. The brown blocks can be found in the Advanced Text palette. Think back to our name bracelet. So the char from at block is deciding which character in the string to read. This is called indexing the string. The length of block tells you how many characters in the string, or beads on the bracelet. Be careful to choose the greater than or equal comparison. That's the one with the little line under it. If you get this wrong, then your program might crash. Right, I think I'll go and get a glass of water while you slot all those blocks together. Good luck. Oh, and don't forget to slot a call next move block into the on start event handler. Well done for finding all those blocks. Let's just make sure we understand what this code does. So, the next move function is all about indexing into the string to get the letter of the next dance move. Just imagine that name bracelet again, and imagine that the move variable is your finger pointing at the first letter on the bracelet. To get the next move, move your finger to the right by one letter. When you get to the end of the beads on the bracelet and want the next one, you realise that you're at the end and just go back to the start again. The positions of characters in a string are always numbered from 0. Now, let's get our glove to beep a different sound for each of the different moves. This is how Robin will learn the dance, because every time they move their glove into the correct position, it will beep a note to confirm. And they will then eventually learn the moves by practicing it over and over again. The code in the beep move function is quite big again, but there really isn't anything new here that you haven't seen before. It looks at the letter that was stored in the this move variable. Remember that your next move function stored the next move letter in there. There are 4 different moves: left, right, up, flat, each with its own letter, and we'll use a big if, then, else statement to play a different pitch of tone for each of the moves. When Robin hears the note, they will know that they have put their hand in the correct position. By using a different note for each different move, Robin will also hear the different positions, and it will help them to remember the move as they learn to associate a different pitch with a different position. Well, there are lots of words in that beep move function. I don't think I'll read them all out to you. I'll leave the code on the screen for you. I'm off to make a cup of tea while you do all that. Good luck. Well, that was a well-deserved cuppa. Now, let's get the final bit of code written. We're nearly there. The trainer glove will respond to 4 different gestures, so grab them all from the input palette. Here they are: on logo up, on tilt left, on tilt right, on screen up. The final bit of code we need to add to make this all work is another function called check move. I thought I'd leave this to last, as there is something a little bit new here for you to try. We've used functions many times before, and they're super handy things, but sometimes all these variables make the program quite long. So let's look for a more compact way to call a function. It's called a parameter. If you think of a function as a box that can hold any amount of code, then a parameter is like posting something through a letterbox on the front. The function will use the data stored in the parameter to vary what it does. To create a function with a parameter, choose the Make New Function button in the Functions palette. Then click on the Text button at the top to add a text parameter to it. We will call this parameter M. So, M is just a name for the letter that is posted through the letterbox of the function. We can say that the function receives a parameter named M. It works like a normal variable, but it is only visible inside the function. Now, let's call the function checkMove and pass it a parameter. Each time we use it, we will pass it a different parameter, which will be one of the gesture letters that we were checking for. Here's the final code listing. Let's look through it together. When Robin moves their hand up, the onLogoUp event handler passes the letter U to the checkMove via its M parameter. checkMove then looks to see if this move is supposed to be an up move or not. If it is, it beeps the correct pitch for the move, then moves along the move string to select the next move in the sequence. So, If Robin moves their hand to the wrong position, nothing will happen. They will try different moves and eventually find the correct one. They will hear a beep of a specific tone, and then they will experiment to find the next move. Eventually, they will associate different pitches with different moves, and they will remember the sequence for the whole dance sequence. I'll leave the code on the screen for you to slot it all together. Is it time for another cup of tea yet? Don't forget to flash it onto your microbit when you're done. Let's just finish by looking at another benefit of open source software. In a previous lesson, we understood the difference between source code and the binary code, or binaries. Source code is the human-readable version of the program, and the binaries are the computer-readable part. Wouldn't it be good if you could open up a large piece of software and see how it is written? You would be able to learn all sorts of things about software, and you might even find some hidden features you didn't know existed. One of the benefits of open source software is that the license means that you have the rights to read the source code, and because of this, the developers make the source code freely downloadable for you to read and learn from. Well, the MakeCode editor is open source, so how can we look at how it is written so we can learn from it? Click on the JavaScript button at the top of the editor to change into text coding mode, and you will see a version of your program written as JavaScript code. Over on the left of the screen, below the simulated microbit, is now a blue box called Explorer. Click on that, then click on Core. Then scroll down and click on Melodies. Scroll down in the code editor until you see the Get Melody function. Wow, what's this? This is open source software, and we can see right inside it. Now, this bit of code looks really handy. It looks like the MakeCode editor has its own music playback engine inside it that works in a similar way to how the trainer glove works. A list of notes are stored as a series of letters, and these are grouped together into sequences that make up each of the pre-programmed melodies built into the microbit code. Click around the other files in this Explorer to look through the open source code and see what other exciting things you can discover about MakeCode and the microbit. I'll leave that with you to explore for a while. We'll catch up with you at the next lesson. Now, where did I put my tea?